Hey there, if you've wanted to learn SQL, this video is for you. You're going to hear from data expert Alice Zhao talking about the basics of SQL. She does an amazing job making it totally non-intimidating and walking you through what you should be doing on day one to start to build that foundation for SQL, which is an incredibly valuable skill used across pretty much every single company in their data departments. It makes you really marketable, and you don't have to be scared about it. Alice is going to help you get through the basics today. It's a pretty quick video, so hope you'll stick around and enjoy it. Highly recommend.
Hi, everyone. Welcome to the SQL Crash Course. As John mentioned, it's going to be an action-packed, roughly half an hour. And just to get us all on the same page, this presentation is for complete beginners with no prior experience in SQL. So there's going to be some technical terms, but we're going to go over all of them so you'll understand everything by the end. And it's not a deep dive tutorial on SQL coding. If you want one of those, you can check out John's MySQL courses at Maven Analytics. So just some background about me. Again, my name is Alice, and I'm a data science instructor. I create courses for Maven, for O'Reilly, and I also teach at Northwestern University. And in the past, I've held all these roles that you see here, and there was a common thread in all these roles. And it was that I use SQL in all of them. And so then a few years ago, I put together this book called The SQL Pocket Guide that combined all the things I learned from all my jobs. And the first chapter of this book is called The SQL Crash Course. So I have this presentation version of this book today. And then just a bit more information about me. So for Maven, I create a few courses, the Data Prep and EDA course in Python, which is part of the Data Science in Python track, as well as the unsupervised learning course. And heads up, I'm coming out with an advanced SQL querying course next month. Okay, so here is our agenda for today. We're going to start out with some basic terminology, just so you understand all these terms that people are talking about when they say SQL, NoSQL, and so on. We'll go through an example database, and I'll talk to you about all the things that you should look out for when you see a database for the first time. We'll go into some SQL code, and then we'll end with a software demo, all in half an hour. Okay, so let's start with the basics. So I'm going to start really basic and just start with data. So what is data? It's information stored by a computer. So that means it could be information that looks like this, or things are getting a lot more advanced these days. So it could be audio files, images, videos, and so on. So that's data. It's just information stored by a computer. So then the next term you got to understand is a database. So what is a database? It's a place to store data in an organized way. So imagine you have this Lego piece as your data. And if you had a lot of data, it would look like this. But this is really hard to sift through and understand. So you have to organize it in some way. So this is a database for Legos. Now everything is nicely organized. Now, things to know about databases are that there are many ways to organize data. There's no one right way, and there are pros and cons to each approach. So if you think about this in terms of Legos, we can organize data like this, or we can organize Legos like this, but you can also organize it like this or like this. And these are all valid ways of organizing Legos. They all have their pros and cons, right? The one on the left, it might be hard to find the exact shapes you're looking for. The one on the right is probably the easiest cleanup. You just throw it in a bucket, but they all have their pros and cons. So we're just gonna do a quick checkpoint to make sure we're all on the same page. Data is information stored by a computer, and a database is a place to store that in an organized way. And there are so many ways to do so. So we've seen this in terms of Lego, but now let's see it in terms of actual data. So for the databases that are out there, there are two main categories. One group is called SQL databases, and the other group, they're called NoSQL databases. So we're gonna dive into both of these a little bit more. So let's start with SQL. So SQL, which is what you're all here for, stands for Structured Query Language. So the first part I want to highlight here is this language piece. So to demonstrate this language piece, let's say we had a birthday app on our phone, and that app contained all our friends' birthdays. So in English, in the English language, you would try to get information from the birthday app by saying, hey app, when is my husband's birthday? And then in the SQL language, you would then do this code right here, but this is saying the exact same thing as the English language, and then it would give you back May 1st. So SQL is just another language to talk to an app or a computer or program somehow. Okay, so that's SQL, it's a language. So now let's talk about a SQL database. So we already know that a database is a place to store data in an organized way. And then specifically in a SQL database, the way that data is organized is into tables. So if you're familiar with Excel or any other software like that, sheets and so on, you'll know that this is a table. So a table has columns, and then it also has rows. So this is one table, but in a SQL database, data is organized into many tables. So here's one table, here's my other table, and here's my other table. And you can see that all these tables have this column called ID in common. And this whole thing here, this would be called my SQL database. And it's called that because my data is all organized into these tables. And now this table here, in older terminology, sometimes it's called a relation. And so that's why you'll sometimes hear a SQL database called a relational database. So that's a term you're going to hear again and again when talking about SQL. This is a relational database which has lots of tables all connected to one another. And then once you have that relational database, you can talk to it using that structured query language, saying, all right, give me all the information from that birth year. Okay, so we just went through a theoretical database, but I want to pause and just say, SQL is in your everyday lives. These databases are all around you. And the one that you are probably very familiar with is text messaging. So let's say you're opening up, if you have an iPhone, you open up the Messages app and you have this conversation with your friend. That information, that conversation is actually stored in a SQL database. So if you're on Messages on your computer, you can actually dive into this chat DB that's on your computer. And what's stored in that computer are these tables here. So there's a handle table and a messages table, and you'll see it has information about every contact that's in the handle. And the messages table has information about your back and forth and then what you've liked. And then what you can do from there is you can talk directly to that database and you can ask, hey, what are all the messages that have been liked? And you would talk to it using SQL, and then it would return back to you, this message has been liked. So this is something you can actually do on your computer. I just want to emphasize SQL is all around you. You're using it all the time. Okay, so let's summarize everything we've talked about so far. Structured query language, that's what SQL stands for. And a SQL database is made up of tables with data. And those tables are sometimes called relations, which is why you'll sometimes hear the structure of tables called a relational database. And one other thing about SQL is it requires predefined schemas. So I'm introducing a new term here, so let me just talk about what schemas means. A schema, if you think about it, like a schema for a house, it's kind of like the blueprint for the house or what the general structure should look like. So when you're creating a SQL table, you always have to define the structure of your tables first. So this here would be the schema. This is saying, I'm going to have 4 columns in my table, and then I'm going to insert data from there. So this is my predefined schema, and then I'm going to insert data into that. So I'm just mentioning this because we're going to talk about it in just a bit. But this is my predefined schema, and you'll see it's just like if you have Lego organizer, and then you label, this is the red column, or sorry, this is the red drawer, this is the orange drawer, and so on. Okay, so this is your SQL summary. It's basically your database that has a lot of tables, and everything is predefined and it's really structured. So that is the SQL world. Most of the databases out in the world are SQL databases. But then on the other side, you have NoSQL. So what is NoSQL? NoSQL stands for not only SQL. And NoSQL databases have dynamic schemas. So there's no predefined structure, and you can think of it as just you need to store data in some way, so you just put it into a NoSQL database. So this is an example of a really popular NoSQL database. It's called MongoDB, and all the data is stored in dictionaries. So you'll see up here, for Lily, this is her age, but then for Henry, this is his favorite color and his favorite fruit. And you'll notice that Henry and Lily, they have different attributes associated with them. And MongoDB is a really flexible way of storing that data. So in terms of like Legos, the way I like to think about this is a NoSQL database is basically like you have a big room, and then every time you buy a Lego set, you just put it in the room. And it's organized in some way, but it's not highly organized, but it's just a way to store that data. So the thing to know about NoSQL is that there are many types of NoSQL databases. So for SQL databases, it's really just those tables. But for NoSQL databases, you can throw data into a room in a lot of different ways. And then these are sometimes called non-relational databases. So that's when you'll hear those terms: relational databases for SQL tables and non-relational for NoSQL databases. Okay, so we went through all these terms here, and at the beginning, you may not have known what they meant yet, but at this point, you should have a good idea of a database is a place to organize data in some organized way. And then SQL is this highly structured way of organizing data, and then NoSQL is this more flexible way. So to summarize everything, SQL is the language you would use to work with a relational database. And this is what SQL code generally looks like, and we're going to dive into that in just a bit. And then this is what a relational database would look like. It has all these tables that are connected to one another, and then data is stored in multiple tables within a SQL database, and all these schemas or these table structures are predefined. And then on the other hand, you have the less rigid way of storing data, which is using NoSQL, which doesn't have the predefined schema, and sometimes it's called a non-relational database. Okay, so those were the basics for you, but hopefully you have a good idea of the difference between SQL and NoSQL now. But again, the focus of today is on SQL. So we're gonna go through an example database. So I'm just gonna put you in a scenario. Imagine that you work at a school, and right now you need to keep track of all your students and your grades. And at the moment, you're keeping it all in spreadsheets. That's pretty typical. So right now your data is all in all these spreadsheets. But the problem is that your data is in multiple spreadsheets, and you are having some issues with this. One issue is that there's no single location for your teachers to access the data. Another issue is that people keep editing the data, and you really need to lock down the information so people don't overwrite things. And then another issue is that your student body is growing, and you just have too much data to manage. And in these situations, these are all great reasons to move from spreadsheets to a SQL database. Because with spreadsheets, you might have different versions of it everywhere, and then there's no central version that everyone can look at. But with a SQL database, you have one central place to store your data. With spreadsheets, anyone can edit everything, but with SQL databases, you can specify those permissions. And then of course, SQL can handle a lot more data. So these are all great reasons to move from spreadsheets to SQL. So let's say you create the student grades database. And to start, you have these two tables in that database. So what I'm going to do for this section is just introduce some key terms that people talk about when they're talking about databases. So when you have the students and grades table, one thing you'll notice right away is that that first column has an ID in it. And this is really common when you're talking about SQL. So this column with the ID, this ensures that every row has a unique identifier or a unique ID. And the technical term for this column is called a primary key. So that's just say, this is the unique ID for this table, and it makes sure to uniquely identify each row. So that's the primary key. That's a term you'll hear a lot. And then you'll notice that these rows here, these rows are actually connected to one another, because you see Alexis has a student ID of 101, and then the grades table, student ID 101 is associated with all these courses and grades. So the idea that I'm trying to get across here is that you can match the rows in one table with the rows in another table. And that's a huge part of SQL, is that all these tables are connected within your SQL database. So one relationship to note here is that this one student within the students table matches with many grades here. So that idea, many grades here. So that idea of one student to many grades, that is called a one-to-many relationship. So we'll talk about that a little bit later as well. And then here you see this student ID in this second table matches to that student ID in the first table up here. And this purple column here, this is called a foreign key. So this isn't as high priority to know, but you may hear this term when you're talking about databases. Basically, this field in that second table, that student ID, that purple area, because it matches the unique ID in that first table, that purple field is called a foreign key because it's a unique ID in the student's table. So that should make a little bit more sense once we do the summary for this section. But then, okay, we are at the summary for this section. So in this slide, I'm going to summarize everything that we just talked about in this section. So I introduced you to two different tables, the students table and the grades table. And we saw the full tables on the slide, but typically what you'll see is an image that looks like this. And this is what you'll see to summarize a database. So we had a students table in this database and a grades table in this database. And this image here is called a data model. If you are at a new company and you want to better understand their database, typically what happens is they'll give you a big sheet of paper with all the tables, and then you'll see how they are all connected. And so if you look here, the first thing to know, again, is that there are two tables. You have the students table and the grades table. And then everything listed under, those are all the columns that each table has, which we saw in the previous slides. Now, this was the one that I said is really important to note, is the primary key. So that's the unique ID for each table. And so for the students table, we have the student ID, and the grades table, we have the grade ID. And then you see there's PK next to that, which means primary key. In some data models, you might also see like a little key icon there. And then this fork here, what that means is a one-to-many relationship. So one student matches to multiple rows in the grades table. And then we had this foreign key here. So I think the foreign key makes more sense in this visual here, but the idea of a foreign key is that this column in the grades table matches the primary key in the students table. So that's why it's called a foreign key. Okay, so this is your database summary. These are the key terms you need to know when you're reading a data model. And at this point, you should have a good idea of what's in the students table and what's in the grades table. And from here, we can dive into our SQL code. All right, so let's get coding. So at this point, we have covered the basic SQL terms and concepts. We have this database that we're familiar with. We're able to do two things from here. You can either read data from a database or edit data in your database. And I would say most people start here. So if you're a data analyst or data scientist, you're going to spend most of your time reading data from a database. But then if you are a data engineer or a database administrator, then you're going to be editing data in the database. So because this is a crash course, we're going to start with reading data from a database. So to read data from a database actually has a specific term in SQL. It's called to query data from a database. And remember, SQL is called structured query language. So querying data from a database is all about reading data from the database. And this is the most basic SQL query you'll see. Select all from my table. So what that means is give me all the data that's within the table called my table. So you may have noticed here that I just used query in two different ways. The top one was a verb and the bottom one was a noun. It's basically when you're writing SQL code, it's almost all queries. So you're querying data from the database to get data, and then you write a SQL query to do that querying. So again, just I wanted to note that there because that might be confusing to beginners. All right, so let's break down this really basic SQL query. So these two words here, these are keywords in SQL, which mean they have a special meaning in SQL, select and from. And then my table is a table within my database that has some table in it. This star here means all columns, and this semicolon here means this is my SQL statement. I am done with this line of code. So this is what you'll always see within SQL code. And some things to know about this query here is that SQL is case insensitive. That means if you write select uppercase versus select lowercase, that's going to mean the same thing. But typically, keywords are going to be in all caps, and then everything else is going to be lowercase. That's just the standard for SQL code that you'll see out there. But it's case insensitive, so you can really do whatever you want. But I highly recommend making your code readable. Okay, so if you remember, this was our students table that you're more familiar with now. And if we did a select all from students, remember, that's going to give me all the data from the students table. So this is what I would see as my output. And then if I do a select student name from students, that's only going to give me the student name column. And if I do student ID and student name, that's going to give me both these columns here. So you've probably seen a pattern here, which is whatever you state in that select line, that's going to be the columns you want to display. So you can do a star to show everything, or you can specify the exact column names that you want. So whatever is right after that select is the columns. And then this from place, you can see right here, after the from, I've put students in all these situations here. And what happens after the from keyword is you specify what tables you want to pull from. And in this case, we only have one table, which is the students table. So this select and from, these are two common keywords in SQL, and they're both called clauses. So this is the basic structure of a SQL query, and we're going to go through all 6 of these clauses throughout this presentation. But I just want to note that this whole select line, this is called the select clause, then you have the from clause, and so on. So far we've gone through select, which is what columns do you want to display. We've gone through the from, which is what tables do you want to pull from. And then next, let's talk about the where clause. So now we have both of our tables in our database. And what I'm going to do now is select all. So I'm going to take all the columns from the grades table, which is the table on the right, and I only want the places where the student ID is 101. So if that happens, that filters my data. So at the end, I only get the results where the ID is 101. And we can go even more complex with this. So this combines a lot of things you've learned already. We have the select, which is going to give me the student ID, course name, and final grade, those right 3 columns from the grades table. And then I only want places where the course name is, those are 3 tables. And then I only want places where the course name is entered as SQL, and then the final grade is greater than 90. So you can see there's actually only one row that matches both of those conditions, which is the first row. And so then this here is my final output. Okay, so at this point, we have gone through 3 of the 6 main clauses, which are select, from, and where. And now from here, I'm actually going to skip a few and go down to the order by, because the group by and having are a bit more complex, but we'll come back to those. But next, I want to go through the order by clause, which is all about how to sort your data. So here we have a query that's saying select everything from the grades table, and then we're going to order by that last column and then descending. So here's my last column, and then descending means from greatest all the way to smallest. And you can see here is my final table. So everything looks just like my regular table, except that final grade is sorted. And then here is a little bit more advanced of a query, but you can see here what I'm doing is I'm saying select distinct course name. So here's my course name column. And when I do a distinct course name, it's going to take a look at all those course names and only return the unique values. And then once it gets just the unique values, which are just 3 classes, then it's going to order by course name. So it's going to order them alphabetically. Okay, so that is your demo of these 4 clauses here. Now we're going to move into a little bit more advanced one, which is called the group by clause. And the group by clause allows you to split rows into groups. So let's talk about what that means. So here we have our grades table once again. And this is a more complex query than we've seen so far, but let's break it down step by step. So let me just start by showing you what the output's going to look like, because I think that's helpful before I go through each of these step by step. But my goal here is to show each student's average grade. And so at the end, this is what I expect as my output. For each student, this is the average grade I'm going to get, or the average grade that they got. So let's first look at this query and talk about a few of the things we see. The first thing I want to note is that that bolded text is a comment. So within SQL, if you do a dash dash, everything after that will not be run by your SQL editor. Instead, what's going to happen is it's like a note for the human. And then all the code below it is run. So that's your comment. And then here is my group by. So what my group by is doing is it's saying, okay, look at this grades table. And these are all my student IDs for 101, student 101. And these are my student IDs for student 102. And once I do that group by, so that was the grouping step, Then from there, what I want for each group is to return the average final grade. So up here, I'm going to look at this final grade. Here is, those are all the grades for 101. Those are all the grades for 102. And then I'm going to average them. And then this here, this average is called a function. I'm basically applying some calculation to each group of my data. And then finally, this part that goes right after that average final grade, it says as AVG grade. And that part, what it's doing is it's creating the name for this column. It's calling it AVG grade, AVG underscore grade. And this part is called an alias. That basically allows you to rename columns in your output. So we just went through these 4 concepts here, but all those concepts are important when you are doing a group by. So this allowed us to take student 1, calculate the average grade. Student 2, calculate the average grade, and then rename that column as AVG underscore grade. Okay, so one thing I want to note here, if you're slightly more advanced in SQL, is that when students are starting in SQL, one of the trickiest things is when they do group bys, they get an error, and it's because whatever you're grouping by, in this case student ID, that should also be listed in your select clause. I remember when I was first learning SQL, this is just something I had to remember every time. But then now that I've been working with SQL for a while, it's second nature and it makes a lot of sense. But I think when you're first starting, it's just good to know this tip. Okay, so we talked about group by. Now let's wrap it all up and talk about having. So this is the code that we just went through to understand the group by. And this gave us the table on the right. And from here, we can add a line for having. And in this case, we're going to say, from this table that was on the right that we just output, only give me the rows from this output table on the right where the average final grade is greater than 90. And then with that, I would get rid of that last row there. So you can think of having as a filter for your group by data. So that's really my tip here, which is you don't use having as much. You would only use it if you have group data, that group by clause is present, then you can filter that output with the having. Okay, so these were the 6 clauses we just went through. Oops. So these are just the 6 clauses we just went through. And with all this, you can now understand an even more complex query. So this might look super intimidating, but you actually understand each part of this query now. So let's go through it clause by clause. So our goal here is to return students with an average grade above 90, and you can see only Alexis exists at the end. So what is happening here? With our select, we're saying return the student name and then return the average final grade and call it average grade. You can see here, select is what columns you want to display. So you can see that here. And then from, that's where do you want to get the information from? And in this case, we're getting it from the students table and the grades table. We're joining those together, which is a more intermediate topic, but the idea is, in this case, the students table has the student name, and in the grades table that has the grades, and we want the name and the grades. So we need to combine those 2 tables. So here we have students and grades, and then here are the 2 columns that match, the primary key in the students table and the foreign key in the grades table. And then from there, I want to filter my data. So I only want to do this calculation on grades where the final grade is not 0. So you can see I'm only taking the final grades that are not 0. With a group by, this is what we just went through. I'm saying for this student, Alexis, give me all her information as 1 row. For this student, Brianna, give me all her information as 1 row. And we have to include that in the select clause, which I mentioned earlier. And then this average final grade is for each of these groups, what calculation am I going to apply? In this case, it's average. And then that's how we take the average of these final grades here. And that's how we get these 2 outputs, which is the yellow and the teal from the 2 tables. And then with that, we do a having. And the having allows us to filter our group data and only return Alexis here. You see, without that having, we would have returned Alexis and Brianna, but because we only want grades over 90, then we only return Alexis. And then finally, our order by allows us to sort our data, and in this case, we just have 1 row. But this shows you how you can use all 6 clauses together. So we just went through a query that contained all 6 of these clauses here. So you should be pretty proud of yourself for being able to walk through that step by step. Now, one thing about SQL queries is that your clauses must always be listed in this order. That's just one of the quirks about SQL. And there are many mnemonics out there to remember the order of the clauses. This is the one that I like. Start Fridays with grandma's homemade oatmeal. And then you can see it matches the select from and then all the clauses, so on. Okay, so the summary for this section is that if you're a beginner starting with SQL, you will start by querying a database, which is reading data from the database. And then within your query, these were the clauses, and they must always be written in this order. So just a checkpoint here. What have we done? We've learned the basic concepts and terms for SQL. We got familiar with our data. We understood now the structure of a SQL query. The last step is to practice coding. So with this, I'm gonna just do a quick software demo for you because everything we've done so far is in slides, but you probably wanna see what this actually looks like. So your question right now is, okay, we see this in slides, but where can I write SQL code? And the answer is so many places. So we'll talk about each of these in a bit more detail, but let's start with our DBMS software, and then I'm gonna give you a demo of SQLite and dbeaver. So RDBMS, what does that stand for? It stands for Relational Database Management System. And now you know what a relational database is, right? It's our table, all our tables that are connected to one another in one database. And then a management system is just a software that allows you to deal with that. And so RDBMS is basically software that allows you to work with a database, and it's a place where you can write SQL code. And there are so many options for RDBMSs out there. These are 5 really common ones, and you'll see 3 out of 5 of them are open source, and then 2 of them are owned by companies, and then you have to pay to use them. And the reason for that is because they often come with a lot more features that are useful for big companies. But you'll see here that some software like MySQL is often used with web development languages. Postgres is often used by data scientists and machine learning engineers, and SQLite is really easy to use, and that's the one that stores your messages data. Okay, so a fun fact, I think this is a slightly fun fact, is that SQL syntax varies slightly from software to software. So you'll see that if you want to return 10 rows of data from a table, then it looks slightly different in all these RDBMS softwares here. But I would say the main takeaway here is when you're Googling SQL syntax, just include that RDBMS in your search, just like this, and you'll get the right syntax. Okay, so the takeaways here is that there are a lot of software options. These are just the ones that are on a local server, and then the ones on the right are cloud-based, meaning that the data is stored on the cloud. And each one has slightly different syntax, but truly the core concepts are the same, what I already covered with you, and you should be able to work with any of them. So here are some free resources for you. SQLite is the easiest setup for your computer. And then if you want to start writing basic SQL, you can even use a web browser and type SQL code in a browser. So that's a good resource. And then here are 2 YouTube videos that I've created that go into SQL in a bit more detail. And you can try those on your own after Open Campus. So I'm going to quickly demo SQLite for you. I just want to show you what that looks like. Let me just open that up again. Okay, so here is my terminal. And from here, I can go to my desktop. And then from my desktop, if I type SQLite, and then I can open up this student grades database, like here. And then here are all my grades. Here are my tables. So from here, I can start writing code right away. I can do select all from students, and there is my table. So you can see here that basically you can start writing SQL code in a very simple way, just using SQLite on your computer, and that's available for all Mac users, and then you can download it within a minute or 2 on a PC. Okay, there's also database tools out there. So database tools use a graphical user interface. So you may have seen that that didn't look really pretty as a really pretty place to write SQL code. What you can do is use a database tool, and a database tool will provide you a nice interface to write SQL queries. So for each of these RDBMS options, there are tons of database tools you can use. So the one specified here is the most common one for each RDBMS. And then there's also dbeaver at the bottom, which is a free one that I really like to use. So let me just show you what dbeaver looks like. So dbeaver is an open source one. Toad is another really common one that you'll see that costs money, but they all have really nice features. And you can see right here, I'm in dbeaver now. And from here, I can connect to my SQLite database. And then I can open up that student grades database. And if I right click, I can write a new SQL script. And I can say select all from students. And now, type here. And now here is my table. So you can see that this is a much better way to write SQL code using a database tool that provides this nice user interface. And finally, you can write SQL code in many other coding languages. So programming languages are used to do everything with computers that is out there. And basically, if you're coding, you're working with data. And if you're working with data, you need a database, which means you need to use SQL. So if you're a developer, you're often using these languages and you need to store web data. If you're an engineer, you're often using MATLAB and you might need to collect sensor data. If you're an analyst, you're often working with Python and R, and maybe you need to analyze customer data. And in all these cases, you can use SQL. So what happens if you're using these other programming languages is what you can do is use SQL code to connect to a database. So let's say I'm using R and I want to connect to these two databases here. I can download something called a database driver, which is just some software that allows me to connect to those databases. And what that will allow me to do is, this is R code here. So everything around is R code, but that purple part, I can write SQL code within R. And then this is the same in Python. I can write that SQL code within Python. So this hopefully just shows you, that there are so many places where you can write SQL code, and it's really the best supporting language out there. Okay, that is your crash course for today. And I just want to show you here, this is a one-pager you can use. If you want to remember everything we learned today, this is your one-pager for today. Okay, I'm going to pause there, John. That is my whole presentation.
Amazing, Alice. I wanted to cut you off and transition into questions before, but the chat has just been so overwhelmingly positive. Like, oh my gosh, Alice is amazing. Where can I get private lessons with her? Give me more courses, all that stuff. And I totally agree. I feel like I'm a great SQL instructor until I sit through this. So thanks for making me feel bad. You're absolutely amazing at this, and just hope folks in the audience have gotten a ton out of it. Let's transition into Q&A real quick.
Hey there, hope you're enjoying the video. Sorry to interrupt, we'll get you right back to it. Right now, Maven Analytics is offering a deal that was just too big not to share it with you. We've got an early Black Friday sale, and you can save up to 50% off of Maven Analytics paid plans. So if you've been considering learning Excel, SQL, Power BI, Python, Tableau, and everything else that you need to become a data analyst or accelerate your career, now is the perfect time. Check it out at mavenanalytics.io. You can see the Black Friday offer in the banner at the top of the screen. You can't miss it. Again, if you're on the fence, there's never been a better time. We don't do a lot of these sales, so I hope that some people will take advantage. Now, enjoy the video. I'll let you get back to it. Thanks.
Here's a great one. One of the highest upvoted questions from Hamza. What is the right way to showcase a SQL project? Often see analysts just showcase their SQL queries on their portfolio. Alice, any advice for somebody who wants to show off their SQL skills in a project portfolio?
Yeah, see, I do understand that this is a tricky one. I would say showing the SQL code is one piece of it, because you do want to show that you have organized code and that you have comments and everything like that. But then I would say just having some insights at the end is really helpful. Yeah. So it's not that you can write the SQL code, but also that you know what the takeaways from that is. So I always like to start with my insights and then show my code after.
Yeah, like giving it that business lens and like, what are we actually going to do with the output, right? And to me, I think that I always tell people, if you just change the framing, it's not a SQL project. It's an analytics project that uses heavy SQL. So like then you're right, because like then you're attacking a business problem, you're delivering insights. You might even decide to include some visuals, which it's not going to be in SQL. It might be done in Python. It might be done in Excel, Power BI, whatever. But like you're delivering it just like you would in the real world. Like if, say, I was running marketing and Alice was a marketing analyst, she wouldn't hand me SQL code as the project, right? She'd like show me some charts and say, hey, here's where you should spend your money differently based on the data that I analyzed. So try to mirror the real world as much as possible. Definitely don't just give people your code. No one wants to read your code when it's out of context, you know? So yeah, awesome. I love it. Let's go to another one here, and we're going kind of fast and furious. This is a great one from, I think it's MD, I think Mohammed. How can I leverage common table expressions and temporary tables for complex data? What strategy should you adopt to efficiently join multiple large tables in SQL without sacrificing query performance? Wow, so kind of a lot to unpack here, but maybe talk a little bit about CTEs and subqueries and temp tables, and then if you can get into efficiency stuff, that's cool too.
Yeah, absolutely. So CTEs are basically ways to write a query. It's like kind of like subqueries. It's like queries within queries, and I highly recommend them for making efficient queries. So often when you're joining two large tables, that takes a really long time. But what you can do is when you take CTEs, you can filter down those tables first before joining them, and that helps your query performance. So I would say, yes, use CTEs whenever you can. I actually have this YouTube video that talks about CTEs and subqueries and practical tips, and it addresses a lot of these things here. So I would say, basically, my approach to using CTEs and subqueries and temp tables is whenever you can break down a big problem into smaller pieces and do it step by step, you can save that first step as a CTE, the second step as a CTE, and then when you run that, it does help your query performance.
Awesome. And that's on our YouTube channel at Maven, right? Is that? Yeah. Cool. Yeah, so I'll grab the link there shortly. Let's quickly keep these questions moving, just because we'll jump onto the other one. So thank you, Alice. I think that's perfect answer. Let's see. Ooh, should I learn SQL or Power BI first? From Jonathan. What do you think about that, Alice?
Oh man, I'm a little biased here, but I think SQL. Like whenever I have analysts coming to me who know Excel, I'm like, learn SQL next. When I have data scientists coming to me who know Python, I'm like, learn SQL next. It's the foundations for everything. So that's
you'll use it as an analyst, you'll use it as a data engineer, you use it as a data scientist, versus like that's not necessarily true with Power BI. I don't think Power BI is the wrong thing to learn. Like second, if you were really excited about it, if your company used it, you thought you could get mileage, I don't think it's necessarily wrong. I always tell people, Excel should be your first stop if you're like brand new, because it's the least intimidating. And then I think either of those two, Jonathan, SQL or Power BI is an awesome one. I'd probably lean SQL just because that's what I did, and I've gotten so much mileage out of it in my career. But yeah, I think you wouldn't be terrible either way. We've got some more here about CTEs and subqueries. We've got, let's see. Any tips? This is there's a lot of stuff in this one. Any tips for drafting a good data schema and perform normalization of the tables to best organize them? It's like you could talk about this for 30 minutes itself, right?
Well, I'll just start by saying I never come up with the perfect schema first. I always do something that's like rough and that works. Like I'll often start a create statement with no even primary keys. I know that sounds horrible, but just like starting something that works, and then I'll have primary keys, and then I'll be like, oh, this could be split, and then it's really the step-by-step approach. Again, like you can watch Chris Dutton's normalization video to go through the technical details, but that's really my real-world approach for doing this.
Awesome. So yeah, I told you guys this would be fast and furious because that presentation was so good. It kind of took most of the time, but thank you everybody for joining this. Alice, thank you so much. Folks in the audience, please give Alice some love. She is unbelievable, 10 out of 10, fantastic on this. Thanks again, Alice. Thanks, everybody. And we'll hopefully see you at the next one.
All right. Thanks, everyone. Bye.
Hey there. I hope you enjoyed this video. This was part of our open campus event where we ran 24 sessions in front of a live audience over the course of 2 weeks. It was a ton of fun. We did all these live sessions and we opened up our entire learning platform for free. You did not need a paid account to take advantage of all the courses. So folks could learn Excel, SQL, Power BI, Tableau, Python, etc. All the stuff that you need to learn data analysis skills and take your career to the next level. If you missed it this year, keep an eye out. We'll definitely be doing this again next year, probably again in October. We would love to see you there. And the last thing that I'll leave you with, if you're looking to take your skills to the next level right now and you've been on the fence about a Maven Analytics paid plan, we are currently running our early Black Friday sale. This is the absolute best time to pay for Maven Analytics if you want to, so don't miss out. You'll have the opportunity to save up to 50% on paid plans, which is a pretty great opportunity. You can check out all the details at mavenanalytics.io. Just look for the early Black Friday banner at the top of the site. You can't miss it. Hope that we'll see some of you there as well. Thanks for watching.